I'm the president of the society, and my history in blockchain, I've been following cryptocurrencies for 4 or 5 years, and over the last year or so, I've done a few hackathons in the area, and after coming runner-up in one of them, I was sponsored to go to the blockchain competition in the Netherlands, which at the time was the largest blockchain competition in the world. And there I helped develop a decentralized application for identity management using Ethereum smart contracts. And this came runner-up, and the team won about £10,000, I think. So ever since I've also been continuing to research the space, and I want to share some of the knowledge that we've gained ever since. So in this talk, we'll be talking about some cryptocurrencies, specifically Bitcoin, Ethereum, Ripple, Lisk, and a few others as well. Has anybody here heard of any others so far? Yeah, we'll be talking about that one as well. Go ahead, go on. Nano, yes, Nano's a good one. That one was a bit too complicated to talk alongside these. Any others? Yeah, that's a good one as well. Yeah. Litecoin as well. Has anybody here heard of Monero or Zcash? Yeah, they're very interesting in regards to the cryptography behind them. In most cryptocurrencies, you can find out, well, you're to some degree anonymous, but you can, given a public key, you can still see the transactions between two parties. In Monero and Zcash, you can't actually. I believe Edward Snowden endorsed Zcash. That's quite interesting. That's for another day. So in our last talk, it was an introduction to blockchain. We talked about the implementation, specifically of Bitcoin. This time we're going to give a bit of a recap of that, talk about what hard forks are, and therefore how we create Bitcoin Cash, what Ethereum is, what the main differences are, Ripple, Lisk, and some others. So it's not just purely about the cryptocurrencies and the differences, it's also a bit about the implementation. So starting up, what is Bitcoin? So we've got blocks containing transactions. We get a block every 10 seconds in Bitcoin, and they all point to each other, and they're in a chain, so therefore blockchain. The way this works in computer science, we have a thing called a hash function. Basically, given an input, you always get the same output. Given the output, you can't get back the input. So here what we do is we create a hash using a hash function given the contents of a block, using all the transactions. We store this hash in the next block. If anybody tries to go back and change the contents, the transactions in a previous block, that's not feasible. If they try this, it would change the hash generated by the block, and therefore it will no longer match the hash in the next block, and so we know there's a problem, which is why data in a block is immutable. It cannot be changed. In the transaction in the block, the hash will no longer match. In a cryptocurrency, there's a thing called mining. During that, you go through a consensus algorithm. In Bitcoin and Ethereum, this is called proof of work. So what proof of work is, basically, when you create a hash for given a certain block, you want to reach certain criteria. In the case of Bitcoin, you want to have a certain number of zeros at the start of the hash. The more zeros you have, the more computationally difficult it is to get that solution. So a large number of miners have to work together to achieve that hash. That means if you want to create a fictitious block with fictitious transactions, you have to have over 50% of the mining power, the computational power of a blockchain network. So you can get to the hash before all the others, and therefore it's called the 51% cap. With that, you can create fictitious transactions. Moving on, Bitcoin Cash. So Bitcoin was limited by the number of transactions you can have in one block. There's ways to improve this. There's scalability solutions being researched every day. But some of the community wasn't satisfied with that. They wanted to make a more fundamental change, possibly to a consensus algorithm, or possibly to the way blocks are implemented. But there was massive controversy behind this within the community. A major point of cryptocurrencies is that they're trustless, they're decentralized, nobody owns them. This means that no one individual or organization can just go and change how they're implemented or how something works. There is an issue here, meaning that you can't really update them in that case. This was identified in several future cryptocurrencies, and they have a voting mechanism implemented, for example, in delegated proof of stake. You can have something like the owners of the cryptocurrency, well, the people, based on how much of the cryptocurrency you own, you get to vote on future changes. But Bitcoin doesn't have that, so there was a problem. At that point, decided to diverge. So they did what they call a hard fork. You made a copy of the blockchain, including every single transaction. So if you own Bitcoin, you would also own an equivalent amount of Bitcoin Cash. And then they changed the size of the block. So where Bitcoin can only have 1 megabyte per block, Bitcoin Cash can have 8 megabytes per block. So essentially you can store 8 times the number of transactions per block. So every 10 seconds they can have 10 times more transactions. This reduced the transaction cost and also increased the speed of transactions. Now there are problems with this. For example, every time there's a new block generated, it has to be propagated to all the nodes in the network. Every single node needs to have a copy of every single block. So if you have a Bitcoin wallet, for example, you would, in most cases, you would have a copy of the entire blockchain, or at least a part of it. And every new block would be propagated to you. With 8 megabytes, that would be a bit more difficult. It would depend on your bandwidth. If you're in a less developed country where you have lower bandwidth, it causes some problems. There's also some other issues we'll get into in a future talk. Next, we're introducing Ethereum. So, yes?
How much is the number of connections increased by the end of the month by 8?
As a rule of thumb, basically it's by 8 times, more or less. So here, so Bitcoin is what I would call a generation 0 cryptocurrency. Ethereum now is the first time a major change was done. I would consider a major update, a major improvement, and call it a generation 1 cryptocurrency. It was developed mostly it was pioneered by Michel Buterin, who we see here with the rainbow shirt. And it still uses proof of work for now. There's plans to migrate to proof of stake, which we'll talk about a bit later. The implementation doesn't have any side chains, so any sort of massive scalability changes. So the basic implementation is the same, but the major change is that they use smart contracts. So smart contract is basically when a transaction takes place, conditions are met through a smart contract, and a certain process will occur. Now, sorry for the wall of text, but basically, how do you create a smart contract and how do you compile it, how do you push it through the network? You write smart contracts using an Ethereum-specific programming language called Solidity. You compile the code using a compiler called SOLP, which is Ethereum bytecode. Compilation, for those that don't know, is basically just taking complex code in one language and simplifying it to a simpler form in a different language. You then deploy the code, which in this one is what they call the contract, to the Ethereum network. This usually costs money, it costs effort. If it's done with light network, you can set up a test network and do it there. At that point, if you want to actually call the contract, you have to get the address of where the smart contract has been stored on the blockchain, and you need to get the API, which is just a representation of the contents of the smart contract, so of the code basically containing variables, events, and methods that can be called. You can then set up a JavaScript interface to call the contract. The smart contract is run by the EVM, or Ethereum Virtual Machine, which lives on the network. And this is one of the major innovations that you brought. Another interesting thing is, since we have smart contracts, we also keep track of the state of the smart contract for each account. So unlike the Bitcoin, you also you have to keep track of, for example, how much effort they have, the state of each variable. You have to keep track of the account in general. With Bitcoin, you basically just have to keep track of the hash, the nonce, the timestamp, and a few others. So here we'll just show a video talking about how smart contracts in Ethereum can be used to manage supply chains. But there are a lot of other uses as well, like healthcare, finance, insurance, and so on.
How smart contracts can transform supply chains. Let's imagine you decide to purchase a new computer. However, in this case, let's also imagine you're concerned about the working conditions in the factory where the computer was assembled. Or maybe you have a concern about the quality of a specific component inside the computer. Right now, there's no easy way to check where your computer came from and how it got made. The complex web of relationships that provide the materials, manufacture the components, assemble the parts, and deliver the computer to market is known as the supply chain. Hundreds of years ago, supply chains were very simple. Mines and farms provided natural resources to skilled craftsmen, like blacksmiths and tailors, who then created and sold finished products. Today's supply chains are much more complicated, fragmented, and difficult to understand. Hundreds or even thousands of suppliers all around the world contribute to make and ship the computer you just purchased. Most of the time, the various companies don't know about each other, and as a consumer, you likely don't know anything about how, where, when, or under what conditions your computer was made. This isn't just a problem for consumers. Today's supply chains are so complex that even Apple, Dell, or HP has difficulty tracking how their computers get made. Smart contracts could make supply chain management simpler and more transparent. The idea is to create a single source of information about products in a supply chain via a global ledger. Each component would have its own entry on the blockchain that gets tracked over time. Authorized companies could then update the status of a component in real time. The end result is once you receive your computer, you could track every component back to its manufacturer. Theoretically, you could trace the supply chain all the way back to the mines where the raw materials came from. Companies can also use the blockchain supply chain as a single source of truth for their products. They can manage and monitor risks within the supply chain, ensure quality of delivered parts, and track delivery status of orders. Additionally, companies can use smart contracts to manage and pay for supply chains autonomously. For example, a chip manufacturer could be paid immediately upon testing of each individual chip at the assembly facility. This would reduce the need for large contract invoices and the back and forth of refund requests for faulty components. Those same smart contracts could assist with shipping and logistics, tracking valuable products as they travel around the world. Using blockchain, companies can finally have a complete picture of their products at every stage in the supply chain, bringing transparency to the production process while reducing the cost of manufactured goods.
Right, so far we've talked about Bitcoin and Ethereum, which are the main ones you've all heard of. Yes. So far we've talked about Bitcoin and Ethereum, which are the main ones you've all heard of. Now we're going to go into something more fun, something that you probably haven't heard of. We're going to talk about Lisk. So this is a cryptocurrency that uses a different consensus algorithm. The first one we've seen so far is proof of stake. So, delegated proof of stake, which is, okay, there's a typo there, it's delegated proof of stake. What you do is, instead of doing some work or trying to get a hash before everybody else, what you try to do is, based on how much of the cryptocurrency you own, you can act as you can vote for a validator. These validators can then vote. Basically, they can vote for, you can become delegates, and they can vote for which transactions get onto the block and which don't. If people see that a validator is not doing its job properly, they can get voted out. And as a delegate, they get rewards in the specific token or cryptocurrency for doing so. This is also the first one we're looking at, where they support a thing called sidechain technology, which is a thing that can be used for scalability, and a few other things as well. They also have SDKs for development, so you can write smart contracts on it, I believe. You can develop using it on it using JavaScript and I think in Python and quite a lot of other languages. So what are sidechains? We've got a main blockchain, which is in this case the Lisp blockchain, but you can use an SDK to create a copy of it, and you can make changes to it. You can make it more specialized. However, it's not just an entire other cryptocurrency. It's just a completely different blockchain, which you can still communicate with. So you can transfer tokens. So in this case, Lisp tokens from the main chain to the side chain and back. This means that you can create, you can be an organization that wants to create something on the Lisp platform, and you create your own sidechain, and you develop your own application on it. Basically, you create your own smart contracts on it, and you do it using the Lisp tokens, cryptocurrency. And then later on, if you want to use those tokens on a different service that also runs on the Lisp platform, you have to transfer those tokens to that blockchain, and you can start using that service. So that way, you can also split up the transactions instead of everything happening on one blockchain and that getting congested. You can split up the transactions and make them occur on a lot of different chains. Earlier this year, we saw a game on Ethereum called Cryptocurrencies. Basically, it was a smart contract-based game where people generated and traded kittens made on the Ethereum network. And at one point, it got so popular, it took up 25% of the Ethereum network. There are ICOs that people try to do and transactions that people try to do on the network that were getting clogged up, and it raised the transaction fees for Ethereum quite a bit, and also slowed down the transactions. And the issue here is that Ethereum, for example, can allow 20 transactions per second, which for cryptocurrency is pretty good. But Visa can allow between 2,000 and its peak is about up to 20,000 transactions per second. A cryptocurrency can't compete with that at the moment. With sidechains, if let's say you have 500 sidechains and you distribute transactions between all of them, then you would be able to compete. That's the idea, and that's already in the works. There's also an idea in the works whereby they're trying to create sidechains for Bitcoin, and that would provide Bitcoin smart contract capabilities that can compete with more modern cryptocurrencies. We have an entire blog post about 1,300 words on we also posted on the Facebook group, talking about this in a lot more detail. So moving on, ARC. Now this is a fork of Lisp, and its main features are also delegated proof of stake. And it's the first one we've seen so far that supports IPFS, which I will talk about in a moment, and it also supports a thing called Smart Bridge technology, which I believe they pioneered. It's built on JavaScript, unlike most of the others, and it allows development using quite a lot of languages. It's quite good for developers if you want to get in on it and start developing using it. So, what is Smart Bridge technology? The basic idea is you can set up some listeners, and they can transfer messages. You can have messages go through them from one blockchain to another. So the idea is through this you'll be able to call a smart contract on Ethereum, which would be able to make a Bitcoin transaction. And you can even make something much more complicated as well. The idea behind it is quite cool, and it seems to be working so far. And I look forward to actually seeing it be used with a lot of other cryptocurrencies. There's some pioneering things they're trying with a lot of other cryptocurrencies, and they might have something really cool going on in the next few years. Maybe not. It might fail miserably, who knows. And they also support IPFS, which is also recommended by Ethereum if you want to store large files in a distributed manner. So there's no point in using a distributed system, using cryptocurrencies or any other blockchain platform, if you have to access files or you store files in a centralized manner, or while they can pinpoint you. But to store large files on a blockchain at the moment is still quite expensive. You only do that with small amounts of data. So if you have to store some large files, there's this project called IPFS. Instead of storing everything on a central server, you can store on individual nodes. It's a peer-to-peer system. So if I upload a file, it's split up, it's encrypted, and it's stored on a bunch of people's on a bunch of nodes in a network. If I want to access it, I can do that. I'm given an address for it. Yeah, we'll discuss it in quite a bit of detail in another talk, hopefully, or at least when we create smart contracts and decentralized applications, we'll be using IPFS quite a bit there. So look forward to workshops next term. And another one is Ripple. Now this one most people have heard of, but what you've heard of is the cryptocurrency. Now the cryptocurrency was just made as a tool to be used in the network. The network itself wants to be used by banks. Instead of trying to beat other banks, it's trying to work with the banks. It's trying to make them more efficient. So at the moment, banks use something called SWIFT. It's a system basically to transfer large amounts of money. And it's slow, takes 2 to 3 days, and it's extremely expensive. And they take a large fee. The good thing about it is that so far it's quite secure. But still, it's slow. They want to speed this up. We're not showing how much each transaction costs for Ripple, but it's quite cheap, a few cents. And it's not a traditional blockchain. There's no blocks in it, but it is a distributed ledger. It stores accounts and balances and updates them, and it stores them on a large number of nodes on the network. You have to register to become one of the nodes. So there is some centralization there. You have to become gateway on there. And yeah, they want to become platform for banks. It's already working with about 60 banks in Japan to speed up the transactions, and the chairman of a major Japanese bank has said it can be the global standard in the future. So the cryptocurrency Ripple is called XRP. It's mostly used to settle transactions and to pay transaction fees. It's unlike most cryptocurrencies, there's no mining involved, there's no consensus algorithm there, because all tokens have already been mined. There's a controversy earlier in its development as the company that created Ripple owned a large amount of XRP, and that made it less trustworthy, that made it less distributed. One organization owned a large percentage of a cryptocurrency. The Ripple network supports XRP, but it also supports a large number of other currencies. The way this works is you set up, one, you become a gateway, or you become a registered organization on the network. And then you can create a thing called an IOU. An IOU can be used to be exchanged, or it can represent any asset. It can represent 50 pizzas. And that is a fixed value. It does not change. It is not volatile. It can be exchanged for a specific amount. You just have to trust that node. So between two banks, there is trust. If one bank messes up or dies, that information will be stored on the blockchain, and no bank will ever trust it again. So that just kills the business. So there is trust there. If the bank says, "Oh, I created this IOU, it's worth 10 gold bars," and transfers that to another bank for X amount of, they have to pay a very small amount, very small transaction fee. It gets to them really, really quickly, within seconds, and then they can either exchange that IOU with somebody else, or they can cash it in. We'll just show you an example of it in use.
Ripple, the global real-time settlement network. Consumers and businesses have new and increasing demands for cross-border payments. Ripple connects banks around the world and allows them to offer real-time cross-border payment services to their customers. Currently, cross-border transactions require many intermediaries to execute, so settlement takes multiple days. This often creates costs and risks that make it difficult to meet today's market demands. Ripple enables cross-border payments to execute directly between banks within seconds, and provides the banks end-to-end visibility throughout the whole process. Ripple is infrastructure technology banks can adopt to power new payment services like low-value retail and corporate payments. Let's see Ripple in action, enabling a person-to-person remittance use case. On the right-hand side, you see a bank's mobile app. On the left-hand side, you see Ripple powering the core processes to execute a cross-border payment. Alice, a bank customer in the US, logs into her mobile banking app. Her bank uses Ripple for cross-border payments. She wants to send money to Bob, who lives in Singapore. Bob's bank also uses Ripple. When Alice selects Bob as the recipient, Ripple allows her bank and Bob's bank to exchange sender and recipient's information to meet risk and compliance requirements. This information is encrypted and exchanged directly between banks via HTTPS. No customer information ever touches the Ripple network. Alice wants to send $1,000 to Bob. Ripple queries the banks for their fees and the network for a real-time FX quote. Ripple packages this information to show Alice the total cost of her payment to Bob in Singapore. Thanks to Ripple, banks can provide customers an accurate total cost, delivery time, and delivery amount for cross-border payments, down to the cent, before the payment executes. After Alice approves the payment, settlement takes place over Ripple in 5 to 10 seconds. Simultaneously, Ripple triggers Alice's bank and Bob's bank to update their ledgers. As soon as the funds are posted into Bob's account, Alice is notified. Ripple solutions afford banks access to transact directly, speed transaction settlement to real time, trace funds end-to-end with certainty of delivery, and minimize the total cost of every transaction. With Ripple, banks around the world are already developing new payment products and services for real-time cross-border transactions. To learn more, please contact us at ripple.com.
And one more video showing you the CEO of
Joining us now, Brad Darlinghouse is the CEO of the cryptocurrency developer Ripple. Ripple's XRP token has surged more than 500% this year. Brad, nice to have you here. First of all, just tell people what exactly Ripple does, because it's not just the currency, also you're very involved in blockchain. Absolutely. So Ripple sells... Joining us now, Brad Darlinghouse, real-time settlement between banks. We sell technology to banks to do that.
And the banks are getting on board with this because I know there's a lot of paper pushing and also a lot of money attached to those settlements.
For sure. So we have over 100 banks working with Ripple today around the world. I think the vast majority of banks, like 99.9% of banks, actually are paying other banks, the kind of the global money center banks like JP Morgan or Citibank, to make those settlements. So a lot of the banks are very excited about democratizing how these global payments flow. There's a belief that, you could transform the global payment system over time. Although then the alternative argument is you need a centralized. You can't have it decentralized, that it actually benefits from efficiencies. I would assume you come down on the left.
Yeah, for sure. I think anytime you can do something without that central counterparty, you're going to reduce friction, which is measured by time, cost, speed. So if I remove that central counterparty going direct from point to point, you can skip going from the Bank of David to the Bank of Morgan to the Bank of Mike. You just go directly to the Bank of Mike.
So if the immediate opportunity is efficiencies in this area, the actual kind of nuts and bolts sort of plumbing of the financial system, how does that relate to the value of the Ripple tokens or of the Bitcoin or cryptocurrencies? They're taking on a separate life, it seems, from the future of adoption of this technology.
It's a great point, and I think one of the things we all have to remember is that the value of a token over the long term is really going to be driven by its utility. What problem is it solving? How big is that problem? How many customers do you have? There's no question there's a lot of hype in this system, and I don't actually think that's a good thing. For Ripple, we use this digital asset called XRP to settle liquidity needs between banks. So today there's $27 trillion parked at different banks around the world so they can make payments between each other. Our view is you can use a digital asset like XRP to do that in real time. Because XRP has been so efficient, it settles a transaction about 3 seconds compared to
So it just
Bitcoin.
passes through that currency for that period of time.
That's correct.
Hey there, thanks for checking out Candy.
Joining us now, Brad. Yeah. So, thanks for coming. Up next is a guest talk coming in on the 2nd. It's financial services on the blockchain, future of credit. It's their head of machine learning and one of the blockchain developers as well, coming to give a guest talk. And on the 30th of November, we've got how is blockchain technology revolutionizing air travel? It's an airline company, well, it's a company called Amadeus. It's a multi-billion-dollar company that works with about 150 airlines. They'll be giving what is pretty much an exclusive talk regarding how they're starting to use blockchain in the industry. And after this event, there'll also be free pizza, so do show up. And our other events, on the 9th, we're going to have a talk on consensus algorithms. We'll be talking about proof of work in more detail, proof of stake, delegated proof of stake, and proof of authority. On the 23rd, we've also got a talk on security vulnerabilities in blockchain and how they're being dealt with. It's most likely collaboration with CyberSoc. And yeah, please give us feedback and check us out on Facebook. We are quite new at this, so if there's any improvements we can make, or how we can make the talks more entertaining, or if we've gone too quickly, if we've gone too slowly, so on, just do let us know. You can be harsh. And yeah, thanks for being here. Are there any questions? Yep.
Yes, you mentioned that the XRP tokens are fixed in value, but then later in that video it seems to show that the value has risen.
Quite. The XRP token is volatile, so it's basically like a normal cryptocurrency. However, you can create is as a node of the network, you can create a thing called an IOU, which would be whose value would be fixed. So it would be, you can exchange it for given assets. So if I go back to the slide. Yep. So the XRP itself is basically normal cryptocurrency, but after transactional network goes through IOUs. So the main usage of XRP would be to pay for transaction costs, and the more people using the Ripple network and using XRP to sell those transaction costs and to make those payments in the middle, the higher the value of Ripple would get. At the moment, there's a lot of people purchasing Ripple, the cryptocurrency, the token, because they're treating it as a cryptocurrency, and they're inflating its value rather than looking at what it's actually being used for and what it was created for. So the value of it would really depend on how many banks really start using the Ripple network.
So is there any connection at all between XRP and IOU?
You would be able to, I believe, exchange XRP for an IOU. So it would be make a transaction. So they're separate tokens. So they would have separate values. So an XRP could be worth a certain amount of, let's say, dollars. You can have another IOU that's worth a certain number of dollars, and you can make an exchange. If the market exists, you can make the exchange. So, yep.
Which technology do you use for micropayments? Most appropriate?
You could use Nano for micropayments. There's several others as well that you can use for smaller payments.
Which ones are gaining traction around the world for in different regions of the world?
Nano is one of them, but for most cryptocurrencies, whilst they're small, they're very, very cheap to do transactions in, so they're very good for micropayments. But as they get more popular, then you lose that. So what really matters is scalability in this case. Like Bitcoin, when it was worth $1, was pretty good. Now, not so much. But if you can make it scalable, if you can use sidechain technology, if you can use something called sharding and so on to make it more scalable, a few years down the line, it can become quite cheaper then. Anything else? Right. If there's any other questions you guys want to ask, like if you want to come up and ask, feel free. Otherwise, yeah, that's the talk. Thank you again for coming.